what are some things that we can do to make sure that when we're taking these steps that start to define what the choices are, that we leave the room for the kind of broad analysis that I just spent 20 minutes advocating for, and that EPA is spending a lot of money creating the tools that help people do. So how do we make all that work within the regulatory system? We're trying to be one agency here with a coherent strategy and not an agency of creative thinkers on the one hand who see the future and really want to get there and are developing the tools, but then on the other hand, we have people who write the permits and it's the same old stuff and they drive you to do the same old stuff. We're really trying to avoid that. It's not easy, but we're doing our best. So the kind of things that we can do are, one, when we're sitting down to negotiate, what are we going to do? Let's make sure that we've defined the right goal. The right goal is not the kind of curve we saw on the first slide of analyze the relationship between cost and nitrogen removal and pick the least cost or the point where the marginal cost equals the marginal benefit or whatever. That's not what we're doing anymore. We want to define a goal that says, look broadly at the full range of environmental considerations and maybe other considerations that are important, and that's what we're trying to achieve. When we're clear about the goal, let's make sure that as we analyze the different action alternatives, that we're developing the specific information we're going to need to make a good choice in the end. So it doesn't make sense for us to say, yeah, in concept we believe in this broad view, but now go look at nitrogen and look at nitrogen removal versus cost. And at the end, you have that first curve, you don't have any of the information you would need to say what are different alternatives and which one of those is the most sustainable. You need to be, you and we need to be very clear about what information needs to be developed so that when we get to the decision points, we're able to make good decisions. We have all the information we need to really compare against all the values that we want to protect. Okay, so then when we get to the point where we're choosing the options, we're often in the point where we don't know everything, even at that point. We've said, all right, first 12 months of the enforcement order is to develop the plan, look at all the alternatives and develop some options, and then we'll choose which one we're going to do. But at the end of the 12 months, we don't know everything. We've ruled some things out, we have some promising avenues, we think the plan probably ought to include this, this, and this, but we're not sure about that, that, and that. So do we lock in, and this may be particularly true of new technologies, some not even new, but not in widespread use, that we don't feel completely comfortable relying on definitively, but they're promising. So one thing we can do is phase a schedule, and we've often phased schedules where we've said, all right, build this. We all know that has to be part of the solution. We're hoping this other thing could also work and be the rest, but we're not sure yet. So before building the rest of whatever the thing is, it's not our first choice. Let's pilot. Maybe it's composting toilets, maybe it's aquaculture, maybe it's low impact development instead of upsizing your stormwater pipes. It could be a whole array of different things. So let's build into our schedule some time to test new approaches, and then a decision point as to whether we're going to go that way because they've proven that they work, or we back off and try something different. So building those things into the schedule, and there's a growing body of cases now where EPA has built those kinds of approaches into our schedule. And we've been willing to extend our schedule sometimes where it's been needed to accommodate those kinds of approaches. That's always a balancing act because we're usually in the game when there's a really serious environmental problem. And so our impulse is always, let's solve that as quickly as possible. But sometimes we're balancing that against, well, if we rush to that solution, it may in the end be an inferior solution from some other perspective, including environmental. So maybe it would be better to do that over 20 years instead of 15 years if it's going to be a better solution in the end. And then another thing we can do, this is not a complete list, but I'm trying to keep it within the time here, is even we may not even have an idea yet of what the better way is, but we may have a sense that it's coming, and what we know now is different than what we knew 5 years ago. So if we're talking about big problems like this, on the scale of those faced by the Cape, we're talking about long schedules. So let's find ways to build in. 5 years from now, there may well be either new technologies or existing technologies that have by then been really tested and shown that they work, so that something that we thought was the right answer now maybe isn't anymore. And so let's have decision points. Not just, the third one is, let's create phasing and testing. The fourth one is, let's create points where we can actually change our minds and substitute a new approach for an approach that today we think is, we're pretty sure is the right one. But let's realize that sometimes even when we're pretty sure, we're wrong. So let's build in some points where we can change and adapt to new understandings as time goes on. All right, I think that's pretty much what I wanted to say. I hope it was useful. I'm glad to serve as Nick Ashwell to warm up. So,
take a few questions.
Okay. Yeah.
I was wondering whether your models and the interventions just deal with things that EPA has regulatory control over, and up to the second end, because many water quality problems are due to agriculture and livestock management issues. And the second one was there's a lot of natural variability in other broad scale things like climate change and impact, both the models and what the predictions are, and I was wondering how you include those.
All right, great question. I'm glad you asked those. Regulatory authority, yes, we're including things that go way beyond our regulatory authority. There's things on this chart that are, we as EPA has no regulatory authority over many of these things.
Great.
Yeah. Yeah, no, it's great. So we're looking at a lot of things that we have no authority over. We're being a little careful in doing that, and this is one of the things I worry about a little bit with this kind of model, is that people will think we're trying to control the whole world since we're modeling it, but that's not what we're trying to do. And on natural variability, let's see. So you see these jagged lines here are, we built in some rainfall. It's based on historical rainfall records, so there's variability here. So some of that's built in. Climate change is also in here. One of the, let's see, where is it? I think one of the assumptions that you can play around with, because we don't have certainty, we have a pretty good sense of what the direction is, but we don't have certainty on the exact path, is you can plug in whatever assumptions you would like on precipitation changes, both overall precipitation and extreme event precipitation, which drives more and more. We realize how much that drives many of our issues. So that's built in. We have to, if you're going to look out 40 years, you have to look at climate.
Yeah.
Being not a modeler also, I was just curious if this is something you're building from scratch, or if it's you're using some sort of software that's made to do this sort of thing.
We're building on a lot of existing expertise. It's built off of public domain software, the VetSim software. And it's built by a firm that has a lot of expertise and is applying a lot of the techniques that they've used elsewhere. So it's not from scratch.